Very good morning to all. So myself Raghavani, Assistant Professor from the Department of Civil Engineering. Today I am going to explain you about the Structural Engineering 1 class. Okay, in the Structural Engineering 1 class, in the previous class, I have explained about the shear reinforcement of the RCC section. So now I am going to explain you the problem about the torsional strength of the RCC section. Okay, now in the previous class I have explained that all the design process of the torsional strength of the RCC section. Now I am going to explain you the problem about torsional strength of the RCC section. Okay, so please note the problem number 1. A RCC beam has cross section 300 mm into 600 mm. 300 mm into 600 mm and is subjected to the following design process. Bending moment 115 kilonewton meter, and then shear force 95 kilonewton meter, and torsional moment 45 kilonewton meter. Okay, so now determine equivalent moment and shear force. And if the section is to be designed, and the section is to be designed. Okay, are you clear, students? So the problem is an RCC beam of cross section 300 mm into 600 mm and is subjected to the following design process. What are the following design process given? Bending moment. So the bending moment value is 115 kilonewton meter and shear force is 95 kilonewton meter, and then torsional moment 45 kilonewton meter. So here you have to determine the equivalent moment and shear force. We have to determine the equivalent moment and also the equivalent shear force. Okay, so in the design process I have explained all the design process and also the problem in the formulas. So now we can go to the problem. So first we can write the given data. So what are given data is there in the problem? First we given that the cross section of 300 mm to 600 mm. That means the width is 300 mm and the depth is 600 mm. He given that width of the section is 300 mm and depth of the section is 600 mm. This capital means the overall depth. Okay. Now the bending moment, you know already the bending moment or design moment M equals to 115 kilonewton meter, and then shear force. You know the shear force or design shear force V suffix U equals to 95 kilonewtons, and then torsional moment. So what is given the torsional moment? V suffix U 45 kilonewton. So these are data he given. We have to find that equivalent moment. Equivalent moment means M suffix C, and also we have to calculate that equivalent shear force. Are you clear? So now already know that ME formula means equivalent bending moment. That equivalent bending moment ME equals to MU plus PU into 1 plus B by B into divided by 1.7. This is the equivalent moment formula. So equivalent moment formula equals to moment. That means design bending moment plus torsional moment into 1 plus depth of the section divided by width of the section and overall divided by 1.7. So now you know all the values, that just you can substitute with formula. M equals to MU. What is it? Bending moment here 115 plus 45 into 1 plus b by b. That means here the depth will be there. Depth will be there in the 600 mm. You can convert it to a meter, 0.6 meter. And the same, the b equals to 300 mm. You can convert it to the meter, 0.3 meters. So now we can take capital D value 0.6 and small b value 0.3 divided by 1.7. Are you clear now? If you have any doubts here or here, so just I am substituting here the equivalent moment equals to design moment plus design torsional force into 1 plus overall depth divided by width divided by 1.7. Now you can calculate and tell me the value. What is the equivalent moment? So why I am converting into that 0.6 and 0.3. Here it will be there in meters. Okay. So it will be there in mm. Okay. Already this 300 mm will be there and 600 mm will be there. So here 150 will be there in that kilowatt meter. So you have to convert this value also in meters. Then you get the exact units. So now you can tell me that what is the equivalent moment value. So overall here in my calculation I am getting 194.4 kilonewton meter is the equivalent moment. Is it clear? Please check it. Please check the value. Equivalent moment is 194.4 kilonewton meter. Is it correct? Yes. Okay. Now we can go to the equivalent shear. So what is the formula for equivalent shear? Equivalent shear V suffix E equals to V suffix U into 1 plus 1.6 into tau U by B. That means PU by P. That means design torsion. Okay. Now V suffix E equals to what is the V suffix U value? Here the design shear force 95 kilonewtons. So we take 95 place 1.6 into what is the T value? 45 kilonewtons. Now we can take 45 divided by small b value which is 0.3 meters. Now we can substitute 0.3 meters. Then you get V equals to overall 335 kilonewtons. 335 kilonewtons is the equivalent shear force. Are you clear? So that is very simple problem and maybe it will be going to ask for a 5 marks question. Okay. So it is very important topic in that unit number 2. Is it clear? Please check this V value, equivalent shear force. Is it correct? 95 plus 1.6 into 45 divided by 0.3 value is of 335 kilonewtons. Are you clear? Right. You got the same value? Okay. Thank you.